Hello, and welcome to this SRC Learning Essentials series video about BGP Auto-Discovery, or BGP AD, in a VPLS. If you are not familiar with the Service Routing Certification Program, you can learn more by visiting our website at www.networks.nokia.com/src. In this video, we will first describe the purpose of BGP Auto-Discovery. Then we will explain how BGP AD can be used to discover all PE routers in a VPLS and how it can automatically create and bind SDPs for the service. In our lab, we will then configure a VPLS with BGP AD and we will verify its operation. BGP AD is intended to simplify the deployment of VPLS services that use TLDP for service labels. It is responsible for auto-discovery, which means finding all PE routers that participate in the VPLS service. In addition, BGP AD allows SDPs to be automatically created between the discovered PEs. It then signals a service label and automatically binds that label to an SDP without explicitly having to configure spoke and/or mesh SDPs for the VPLS service. As well, when MPBGP is enabled, or already deployed in the network, the same BGP auto-discovery mechanism can be used for both Layer 2 and Layer 3 VPN services. Each BGP update message contains a BGP VPLS NLRI that includes a route distinguisher, or RD, and a VPLS switch identifier, or VSI ID. The route distinguisher is used to differentiate between routes in the network, and each VPLS service must have a unique RD. The VSI ID uniquely identifies the specific VPLS switch instance. The Nokia 7750 SR automatically creates a VSI using the assigned autonomous system and the system address. However, the VSI ID can alternatively be manually configured. The BGP update also contains a Layer 2 info extended community to signal Pseudowire control information, including the Pseudowire status and Layer 2 MTU. And finally, a route target to control the distribution of Layer 2 VPN routes. As BGP AD learns of PE routers participating in a VPLS service, TLDP sessions are established between them and automatically used to signal the service labels. The TLDP pairs exchange the generalized Pseudowire ID FEC element, or FEC 129, to determine the service label to use to reach a specific PE router for a specific service. FEC 129 carries the provision source VSI ID and the discovered destination VSI ID to identify the two PE routers being connected. In addition, FEC 129 carries the VPLS ID to uniquely identify the VPLS service to which the service label belongs. Note that all routers participating in the service must use the same VPLS ID, and it is recommended to configure the VPLS ID using the autonomous system and service ID. A Pseudowire template is configured at the service level, and once created can be assigned to control the automatic SDP binding at the VPLS BGP level. Pseudowire templates are used to ensure that SDP bindings are appropriately configured for the service. They may be used to bind a service to automatically created SDPs. They may restrict automatic SDP binding to manually provision SDPs or to a specific VC type. Pseudowire templates may also assign a split horizon group to the bound SDP, allowing emulation of mesh SDP binding behavior, whereas the absence of a split horizon group allows emulation of a spoke SDP binding. As mentioned in the previous slide, Pseudowire template binding can emulate mesh SDP behavior by assigning all SDPs to the same split horizon group, or SHG. In such cases, broadcast, unicast, and multicast traffic arriving on an SDP is flooded to the SAPs but not to other SDPs belonging to the same SHG. When no SHG is assigned to the Pseudowire template, the service will emulate spoke SDP rules. In this scenario, broadcast, unicast, and multicast traffic arriving on an SDP is flooded to all other SAPs and SDPs in the service. Next, we will move to our lab environment to complete this case study. First, we will configure MPBGP on all PE routers to allow the exchange of Layer 2 VPN routes. Next, we will create a Pseudowire template to emulate the mesh SDP behavior and bind the VPLS to automatically created SDPs. Then, we will configure VPLS 20 on all PEs, making sure to enable BGP AD and assign the provisioned Pseudowire template. The RD, RT, and VPLS ID will be configured as Autonomous System VPLS ID, which is 65,000:20 in this example. The VSI ID will not be configured and will be automatically set to Autonomous System system address. Finally, once the configuration is complete, we will verify the BGP AD operation. Alright, let's start the lab for BGP Auto-Discovery. The first step is to configure MPBGP sessions between the PEs to exchange L2 VPN routes. To save time, I have already configured the BGP sessions, so we just need to enable them to exchange L2 VPN routes. So here on PE1, configure router BGP info. And here we can see a neighbor command to each of the other PE routers in a group called MPBGP. To enable the exchange of L2 VPN routes, we must go into the group MPBGP, and enter the command family L2 VPN, and repeat for the other PE routers. And finally PE4. Next, on all PE routers, we must configure a Pseudowire template to emulate mesh SDP binding. I've already created this on PE2, 3, and 4. So on PE1, configure service Pseudowire template 1, create, split horizon group, VPLS mesh, exit all. This template specifies that auto-created SDPs must be used when binding the service to a transport tunnel. It assigns a split horizon group to the bound SDPs in order to allow emulation of mesh SDP binding behavior. Let's now configure VPLS 20 on the PEs. And again, this is already configured on PE2, 3, and 4. So here on PE1, configure service VPLS 20, customer 1, create, and assign the route distinguisher and route target, BGP, route distinguisher 65,000:20, route target 65,000:20, and assign the Pseudowire template. Pseudowire template binding 1. Now we can configure the VPLS ID. Note that the VSI ID is by default set to 65,000:10.10.10.1, which is the autonomous system the system ID of PE1. So we don't need to explicitly configure it. Back, BGP AD, VPLS ID 65,000:20, no shutdown. Finally, let's add the SAPs and then enable the service on all PEs. On PE1, back, SAP 111:20, create, back, no shutdown. On PE2, configure service VPLS 20, SAP 111:20, create, back, no shutdown. And then just enable the service on PE3 and 4. So configure service VPLS 20, no shutdown, and the same here. All right, the configuration is now complete. So we can verify BGP AD operation on PE1 by running show service ID 20 BGP AD. And here we can see that BGP AD is administratively up with a VPLS ID of 65,000:20 and a prefix of the system ID, which is 10.10.10.1. The show router BGP routes L2 VPN BGP AD command can verify that the layer 2 route table contains BGP AD routes. And here we can see that each PE router receives one BGP AD route for each of the other PEs. We can also run show service ID 20 L2 route table BGP AD to show the routes learned by the service itself. And again, we see one route to each of the other PE routers with an origin of BGP L2 and the SDP binding ID. So now that we have verified BGP AD, let's verify that SDPs have been automatically created to the other PEs. So show service SDP. As expected, we see an SDP to each of the other PE routers. Also notice the LB flag, which indicates that these SDPs use LDP LSPs and were signaled by BGP. Running show service ID 20 base allows us to verify the automatic SDP binding creation on the VPLS 20. Note that each binding is created with the type of BGP AD. Finally, let's now move to the CE device R5, where we can test the end-to-end connectivity. Ping 192.168.20.6, which is the address on the other CE device R6. And as expected, the ping succeeds. And that ends this lab on BGP AD and a VPLS. Thanks for watching, and see you next time. Content for this video was adapted from the Nokia Virtual Private LAN Services course. You can access the complete course via any of the 3 learning formats shown on this page, as well as get remote private access to a Service Router lab to complete the course lab exercises. If you are interested in obtaining an SRC certification, this table identifies the recommended courses and required exams for each of the 5 available certifications in the program.